Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah wassalatu wassalamu ala Rasulillah amma ba'du. Alhamdulillah, in this moment we can continue again to study about competitive programming in order to prepare for IOI and the other competition. And then Assalamualaikum warahmatullahi. Before we start our lesson, let's pray together. Allahumma inna nas'aluka iman nafi'an wa rizqan thayyiban wa amalan mutaqabbala. Allahumma inna na'udzubika min ilmin la yanfa' wa min qalbin la yakhsha' wa min nafsin la tashba' wa min da'watin la yustajabu laha. Allahumma la sahla illa ma ja'altahu sahla wa anta taj'alul hazna idza syi'ta sahla. Rabbi ishrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Amin. Alright. And then in the last meeting, we still discussing about some interactive problem, and sometimes interactive problem is harder, but but I think it is they are more challenging. So and we like a challenging problem, right? So please enjoy the problems. And we already discussing about some problem until problem 8, and any difficulties about the past problem. Let's say in problem D, you already did it. And then in problem E also already got accepted. And congratulations about problem C. I think this is slightly harder. And then in problem 8, you got 50 points. Yeah, Hyan got 50 points, right? Got accepted in first subtask and partial point in the last subtask. Is there any difficulties? Maybe here I try to find the bug if there any. Or maybe you still did in with binary search with two queries, right? So the complexity is still 2 times logarithmic n. Why are we talking about why are we taking a constant in problem 8? In this problem, our observation is like this. Because if we query some value, then the response will be sent in the next query, right? Delayed in one query in one day. So while we waiting for the response, we can query another value, right? So for example, if n is equal to 7, then if we query 3, then the response will be sent in the next day. But while we waiting, we can also ask another value, let's say 5. So the possibility is like this. If the response of 3 is too large, so unfortunately, our query with value 5 is redundant, right? Because it must be too large also. Okay. So this value is redundant, but no problem because the possible answer is small. There are only 1 and 2. Okay. So if the response is too large, then we have one we have one good news. We have a good news that the number of answer is fewer. Okay. So the number of answer is fewer, but the bad news is our query with value 5 is redundant. Our query is redundant because we don't need this response, right? This response must be too large. Okay. And then how about another possibilities that the response is too small? If this is too small, then the good news is our query with value 5 is beneficial, right? It's not redundant. But unfortunately, the bad news is the number of possible answer is more than this, right? More possible answer. So that's why we are not query in the middle, but slightly in the left side. Okay, do you get the point? If we try to ask the middle, so there is no good news here and bad news here, right? All of them same, but one is beneficial and one is redundant. So it will not balance. Okay. And then in order to get the optimal strategy, then we should move it to the left so that we got another good news inside of just bad news here. And then instead of only good news here, we also get another bad news here. Okay. So if we move to the left, then the good news is better, and then the bad news is worse. But if we move it to the right, then the good news is not too good, but the bad news is also not too worse. Okay. Then we should find the best constant, best ratio that our query is balanced between too large and too small. All of the response will be same in in term of redundancy and beneficiality. Okay. And then finally we got the constant is 0.382. So we should set the middle value like this, or we can use a formula like this. So that if if the response is too large, then we get fewer answer. So it should be make the query smaller. But if it is too small, then our query here is not redundant. So we can just continue to ask another query while waiting the response of this query. Okay. Okay. Did you understand? In the future, if we face the different problem, let's say like this. Let's say we change the problem. This is not the next day, but the next 2 day. So the delay is not 1 day, but 2 day. Then how we can find the constant? The observation is like this. With our intuition, if we move it to the right, let's say there is a constant A. This is the ratio is A. Let's say this is A and this is 1 or 100%. So if the value of A is greater, then actually there is two cases like this. If the response is too large or the response is too small, or in this problem we say too big, not too large. At first we should find the complexity of the worst case. Okay. until we get the formula of the complexity of this worst case, and then the other worst case. And then with our intuition, if the value of A is greater, then some formula will be also greater, and the other worst case is just lower. Let's prove it. Yeah. If the delay is 2 days, then the complexity, if all of the response is too big, so the answer is just 1. So the complexity is like this: 2 logarithmic 1 divided by n. Sorry, 1 divided by a, like this. Why? Because if the response is too big, so our query is redundant. So every time we query twice, we only get 1 response. So we multiply it by 2. And then because every time we got the response, we divide it by 1 per a, then the complexity is like this. Sorry, yes, that's right, 3 times. So it is multiplied by 3. Why? Because the delay is 2 days. Or maybe we can generalize the problem. Let's say the delay is m days. So we solve query m plus 1 like this, because we solve query keep querying while waiting for the response, and then after get the response, unfortunately this is too big, and then all of the response is redundant. So just do like this, we move it to the left and then try to find the constant. How to find the constant? We can compute the complexity first. If the answer is 1, then the complexity is like this. But if the answer is n, then there is no redundant query. But unfortunately, here the number of possible answer is still big. So the complexity is just logarithmic 1 divided by 1 minus a n, like this. Okay. And then if the value of a is greater, then this formula is also greater, right? Because the number of possible answer is greater. So if a is greater, let's say a must be between 0 and 1, right? Then if it is greater, then the complexity will be also greater. This is the case where the answer is equal to 1. But if the answer is equal to n, if a is greater, so here the number of answer, the number of possible answer is lower, is fewer. So the number of query also fewer, like this. So if we draw the graph, will be like this. And we know that our performance is based on the worst case. So the worst case between these two solution is here. So if we want to minimize the query, then we should make it here. The value of A should be in the intersection between these two graphs. Okay. So the best value of A is when this complexity is equal to this. Okay. Until this point, did you understand? Or any question? Okay, that's right. Yeah. Yes. All right, let's continue to compute the value of A. There is an equation like this: m plus 1 times logarithmic and in base 1 divided by A equal to this logarithmic 1 divided by 1 minus A and then we can just move it here. So this is divided by logarithmic like this. And then we can change it into logarithmic with base 1 divided by A, 1 divided by 1 minus A. Okay, we got an equation like this. And then what does it mean? It means 1 divided by A to the power of m plus 1 is equal to 1 divided by 1 minus A. And then just move it to the right. This is A to the power of m plus 1, and then this is 1 minus A. Okay, we got this formula. So the value of A is like this. If in the original problem the value of m is 1, then the formula will be like this. And we can just solve it with quadratic equation, right? With ABC formula. But if the value of m is general, then how to find it? Any idea? We should not solve it with mathematics, but we can solve it with programming. Any idea to find the value of A? Not mathematically, but with programming. Yeah, that's great. With using binary search. So we can just binary search the value of A. Let's say try to find the middle value. And then if the middle value here is formula greater than 1, then we should make it lower, make it smaller, and then if the value is less than 1, we should make it bigger. And note that This value is a real number, not an integer. So we should do like this. Let me show the implementation. Okay, you're welcome. Let me open our code interview first. Maybe we can use another link. Okay. Anyone want to try to implement the binary search? If you ever do binary search in a real number, let's say there is a variable m, and the formula is just like this. We want to find the value of a. Yes, you may. Thanks. Yeah, please just continue implement here. Let's say the precision is 10 to the power of minus 9, maybe. Okay. And don't forget to make it a real number. Okay, and then this is the formula. We want to solve for variable a. Because this is double, we can use function pow. Okay, then any invalid syntax? Let's try to compile. Okay, let me. Sorry, I haven't declared the value of m. Let me input m equal to 1. Then the value is like this. So I think we already solved with a here 618, and then this is 382. All right. And then what if m is equal to 2? Then the value is like this. And if m is 3, and so on. If m is equal to 10, then the greater value of m, the value of a is greater. So we got smaller here, but because the delay is higher, then the redundant query is so big. So it will be got the same query if the worst case is the answer is n, like this, because this value is big, but there is no redundant query. Okay, is it understood? Okay, that's great. And then we can continue to the next problem about national treasure. Okay, any idea about the solution of this problem? If we don't care about find the minimum cost, then how to find the answer? Any idea to just find the answer and no need to minimize the cost? How to find it? Use machine individually. This is the problem. National treasure. The problem is like this. There is a cycle with size n. Okay, n times n coin. Okay, yes, if you execute each machine one by one, and how to make it only 2 times n? The value of n is 2 to the power of 8, while the maximum cost we may use is only 2 times n. So try to find the solution that the coin less than 2n. And the solution is correct, but The next step is we may try to find the less cost or minimum cost we may achieve. Okay, let's back to the problem. The problem is there is a cycle with size n, and then we don't know where is the tracer, but we may query like this. We can query some position or some location. Let's say we query location here, here, and here, and here, and also here. And then if we try to query some location here, we will get the response that is the minimum distance between the tracer and the location we query, the location in our query. Let's say if the tracer is here, then we get the response, the distance between this location and the tracer. But if the tracer is here, then we get the response that is the distance between this location and the tracer. Okay, so with Rafiullah solution, we can just query its location one by one. Let's say we try to query in this location. If the response is 0, so there is a tracer here. Okay, but if the response is not 0, we can just query another location. And then if it's not 0, try to query another location and so on until the response is 0. So we got the location. Okay, but unfortunately, the cost formula is like this. The cost is n divided by the number of location in our query. So if we just query one location, the cost is n. But if we query more location, let's say 2 location, then the cost is just n divided by 2. So more location is cheaper and less location is more expensive. So if we query all the location, then it costs only 1 coin. But of course the response will be 0 because we query all the location, so we don't need the response. We don't need the information. So if we only have 2 times n point, so if we just query one location, we only can do it in 2 queries. We can do query twice only. So how to query twice in order to get the location of the tracer? Any idea? Okay, there is a direct message from Abdullah. Can you try? That's right. There is a solution like this. Instead of just query one location and cost n 1 by 1, and then the total coin or total cost is n times n, we can query like this. We can query complement of it. So we query all location except one location. Okay. So if the response is 0, so this location is, there is no tracer in this location. But if the response is 1, then there is a tracer here. Yeah, that's good idea. So because we query n-1 location, so the cost is 2 coins. And then because in the worst case, we have to query at least n-1 times, right? So the total cost is 2 times n-1. So we can get partial point from this. Okay, another solution from Rahulullah. That's right. That is the better solution, I think. We can just query one location and then we will get the distance, right? Let's say we get the distance, but unfortunately we cannot directly conclude where is the tracer because there is still two possible solution. There is two possible location between here or here. We still don't know whether here or here. I think just like the problem detecting code here. The nature of the problem is similar. Okay, then how to make sure which one is the correct location? So we can just make another query here. Let's say here, then if the response is 0, then the answer will be here. But if the answer is not 0, so the correct answer is here. Okay, so the cost will be n plus n, or 2 times n. Okay, another better solution that is not 2 times n. What if after this query with cost n, we can make sure the answer in just 2 coins? Any idea? To make sure the answer in just 2 coins. So the total cost will just n plus 2. Any idea? That's right. We can just combine Rafiullah solution and Abdullah solution. We can just query all of the location except one, and then the cost will be just 2. Okay, and then what should we do if we want to get full score? If we want to get full score, the coin should be maximum is 6, less than or equal to 6. So our solution is still not very efficient because this is 200, still around 200 points. So how to improve the solution in order to get just 6 coins. Actually, there are 3 strategy. I found 3 strategy at least. The first strategy is the cost is 2 plus 2 plus 2, and this is the original solution or the solution of the solution in tutorial. The pro the problem writer, I think, make the solution like this, but I found the other solution that the cost is 3 plus 3 or 4 plus 2, but I think there is no solution less than 6. We cannot solve it in just 5 coin or less. The 6 coin is minimum. Okay, how to solve it with cost just 2 plus 2 plus 2? Here, if we want to get the cost is true, then we solve query allocation at least and divide by 2, right? The number of location we have to query is and divide by 2, that is 128. So like this, let's say there is a cycle and then we want to query a half of it. Okay, after this query, any idea what sort we do next? This is only cost 2 points, right? Or let me divide this into 2 cases. The case with response 0 and the case with response positive, not 0. Okay, if the response is positive, what should we do? Any idea? That's right. If the cost is positive, we can just query like this because we already know the distance. So there is only 2 possible location, right? Like this, let's say there is a cycle here. We have just query here and then we know the distance. So the answer is between here or here. So just make another query like this. And of course the cost is 2. So the total cost will be just 2 plus 2. The cost is just 4 coins. Okay. You got it? All right. Then what if the response is 0? So there are still so much possible answer. It may be here or here or here or here and so on until here. So what shall we do next if the response is 0? Any idea? Leave one quarter and add other quarter to it. Leave one quarter. Okay. If we query quarter, then the cost will be 4, right? How to query a quarter? Do you mean like this? If we query like this, then if the distance is small, then the solution shall be here, because here is impossible, because we know that the answer is must be around here. But what if the distance is big? Let's say more than quarter. Okay, sorry. You mean if upper quarter. Okay, so if we leave upper quarter, so do you mean query like this? And then still costing 2 coins? Leave upper quarter, so upper quarter, lower right quarter. Okay. Then what if the response is 0? Then we still didn't get the answer, right? Or if the response is, if after that we query another quarter, then we already cost 6 coin, but we still cannot make sure the answer, right? Because it may be here or here. Okay, there's another solution. At half quarter related to 0 and half other. Yes, maybe if I'm not mistaken, you may query like this, and then the response may be 0 or positive. If it is positive, then we can directly know the answer. But if 0, so we can just make another query like this, so that we will get the answer directly. Okay. and then the cost is 6. Okay, that's correct. That's right. You can solve it with this strategy. This is one of the strategy, and there are some other strategy. Let's say we can also query in the other half, and then we got the distance, and then we can just query another 2 coins with all location except 1, like this. Then the total cost is also 6. Okay, that is the solution. You may solve it with that strategy. And how to solve in just 2 query, like this, are 3 times 3, between 3 times 3 or 4 times 2. If we want to solve it with cost 4 times 2, then we can query in quarter here. And then if we got the positive response, then we can just query all of them except 1, and the total cost will be 4 times 2. Okay. And then if the response is 0, we got 0 response, then we can query another half. So we can conclude the answer, because the answer should be here, never here. This is not the valid location, and the location should be here. Okay, did you understand about these 2 solutions? Okay, and then how to solve another 2 queries if we want the cost is 3 and 3. Then in order to get the cost is 3 points, we solve query 89, right? Sorry, 86. If we just query 85, then the cost will be 4 coins. But if we query 86, then the cost is 3. So we can just query 86 here. And then if the response is, or we can just try another 86 here. But there is one intersection. And then if all the response is 0, then the answer should be here, right? But if all of the answer is positive, then we directly know the answer. Why? Because it must be here, because this is positive and this is positive. But if this answer is, one of them is 0 and one of them is positive, we also can directly know the answer, because The answer will be here. Why? Because the response is 0. So this is not the valid answer. The valid answer is only here. Okay, you got it. So we can just query 86 here and 86 here, and then the answer will be can be concluded directly. So the total cost is just 3 plus 3 equal to 6. Okay. Any question about this solution? So just try to do one of them. One of them is enough. You may use 3 queries with cost. Each of them is true. So the total cost is 6. Or you can use the second solution with cost 4 plus 2. Or you can also do the last solution with cost 3 plus 3. Okay. Any question about this problem? All right. I think it is easier than problem 8 and Z. So I hope all of you can solve it. And then we can just directly move to problem J. Okay. Did you understand the problem? Have you read all of the description? Okay. You may read it again. Any difficulties when while you reading this description? Sorry, I have to go to the toilet first, and you may discuss this problem to with your friends. Okay. All right. Yeah, let's continue our discussion. Any question about this problem? Or what is the difficulty? What is the difficulties in this problem? What make this problem harder or make this problem hard? In this problem, there is a matrix with size n times m, and then there are some microbes, and there are two types of microbes P and microbes K. What is the difference? Do you know the difference between microbes P and microbes K? Okay, so here in the problem statement said that microbe K will move right each time we accelerate. So this means accelerate. This means we do experiment. Okay. So the basically the all of the microbes is not moving, but if we accelerate it, then all the microbe K will move to the right, and all the microbe P move move down, and we can accelerate T times, so that move to the right T times, and T move to the move down T times. And then the matrix is circular, so if a microbes K move to the right until to the right most, then it will back again to the left most. Okay. Yes, we can do experiment as much as we want until all microbes is all microbe is experimented. Yeah. We can only accelerate 1,000 times, but we may do experiment as much as we want. But not that each time we do an experiment, there should be a microbe, at least one microbe here. Let's say we want to do experiment in this position. That means we put the microbes. So there is no microbes here after we do experiment. So the total number of experiment equal to the number of microbes, right? Because if we do an experiment in an empty location, then we will get wrong answer. Okay. So even if there is no constraint about the number of experiment we do, but of course we cannot do more than the number of microbes. Okay. Okay, any other question? So accelerate means we move all of the microbes, and not that this is circular, so it will back to the topmost again, and this will be moved to the leftmost. And unfortunately, we only get the information like this. Only get the information whether this position, in this position there is a microbes or not. But we do not know whether here is microbe P or microbe K or both of them. So we only know whether there is a microbe or not. And each time we accelerate, then we will get the result, the resulting position after we accelerate. And each time we do an experiment, we will get the information about the number of microbe experiment we did. Let's say there is only one microbe, and here there is two microbes, and so on, until of the microbes is experimented, then the interaction end. Okay. And how to get partial point? Here, more times we do acceleration means worse, but less acceleration means better. So in order to get the full score, we should not do accelerate more than 9. So the constraint is 9. We may not do accelerate more than 9. And then how about experiment? Here stated that if we do an experiment to one microbe only, then it is said to be successful. But if we experiment more than one microbe or two microbes once, then we will get less score here. So if we want to achieve the full score, we have to always experiment one microbe. Never experiment two microbe at once. But the difficulties here, we don't know whether here there is one microbes or two microbes. So we have to try to find the best solution. Okay. And then there's a constraint here. Fortunately, number of n and m is small. The maximum n and m is 23. And then they are two distinct prime numbers. And then there is at least one square with no microbes initially. Okay. Did you understand the problem? Okay, great. And then how to solve it? If we query on a cell with two microbes, that is we we don't get wrong answer. It is still okay, but we got partial points. We will got partial points like this. This is successful experiment because there is only one microbe, but here is failure experiment because there are two microbes. So in the above sample, there are four successful experiment. 1, 2, 3, 4. And there are two failure experiments. So the percentage or the points will be only 6%. So the point is so small because there are too much failure experiments. Okay. Yes, of course. If we want to get a full score in this problem, then we should always query on cell with one micro. But unfortunately, the information is not given. We only know whether there is a microbe or not, but we don't know whether here one or two. Okay, that is the difficulties. Then how to make sure that the position has only one microbe? Any idea? Any observation you got? Here we will we will use this constraint. We will utilize this constraint because there is at least one square with no microbes at all initially. And we know that at most one microbe K and at most one microbe T. Why? Because if there is more than one microbe with the same type, then all of them will always together, right? So we cannot solve it. That's why there are at most one. But unfortunately, there are two types of microbes. So we have to make sure two of them is not in one position. Okay. And then how to make sure that there is only one microbe? We can do like this. Our target is we want to make the metric empty, right? And then how to achieve that? We can utilize this constraint. Initially, there is at least one square with no microbes. And from an empty location, we can move it by one or accelerate by one so that after we accelerate, then if there is no microbes here, then we got to empty position, right? But if there is a microbes here, then in this location, this must be only one microbe. Why? Because if there is one position after we accelerate from this condition, because there is no microbes here, so the only possibility is B microbes move down. Okay. And it is impossible there is microbe K here because microbes K only can move to the right. But we know that in the previous state, there is no microbes at all here. Okay. So if there is microbes here, so it must be only one. We can make sure it is only one. So we can just do experiment here. So the location will be empty. And also about this location, if here is empty, so there is no problem. But if there is a microbe here, then here must be only one microbe. That is microbe K. And it is impossible microbes be here. Okay. What is the empty cell is in the bottom right? Okay, that's good question. What is the initial empty cell is in the bottom right? Then after we do one acceleration, then we have to check here, because microbe B will do circular here and become in the topmost cell. So we can make sure there is at most one microbes. So if there is microbes, we can do experiment. If there is no microbe, so just left it empty. And also about this location. Okay, you got it. Okay, what do you mean no? It is you not got yet. Yes, if the corner is empty, so after we accelerate by 1, and then the microbe should be moved here, and then if the microbe type is P, then move here. So there are still 2 more empty cells. Or maybe if there is an empty cell here, then if we accelerate by 1, after that this cell and this cell will be empty. Okay, so no need to confuse about in the corner, because the matrix is circular. So we can imagine that the matrix is like this. There are infinity matrix. So when we move here, we will move to the leftmost. So there is a problem about the corner. If the corner is here, then if we move with acceleration 1, we will get another 2 empty cell. Okay, did you understand? Yes, that's right. So if initially there is only 1 empty cell, then after we accelerate by 1, we will get 2 empty cell. Okay, until this point, did you understand? Okay, great. After that, if we accelerate 1 again, then we will get 3 empty cells, right? Okay, and then after accelerate again, then we will get 4 empty cells, and so on. So if we repeat to accelerate 1 by 1, then finally we will get all the cell is empty. Why? Because n and m is 2 distinct prime numbers. So the greatest common divisor between n and m is 1. So like this. Let's say we already get empty cell. Let's say 1,000 empty cell. Or what is the worst case? The worst case is n equal to 23 and m is equal to the previous prime number. What is it? The previous prime number is 19. Okay, thank you. So the number of cells in the worst case is only 437. So after we do acceleration 400 times, then we will get an empty matrix. Okay. Why? Because after this, there's an empty here, here. After that, here, we can always teleport here. And because the greatest common divisor between n and m is 1, so all of them will be empty. Okay. Until this point, any question? Okay. And then how to improve the solution? Because this is, we have done too much acceleration. And the maximum number of acceleration is actually 1,000 times, but if we want to get full score, we should not do more than 9. Okay. Any idea how to improve it into only 9 acceleration? First, we should not move one by one because it is time consuming. Then what should we do? Initially, in the worst case, there is only one empty cell. And then after one acceleration, we will go to empty cell. And then what should we do? Please don't accelerate one again, but accelerate. Yes, that's correct. We can always accelerate 2 times. So the complexity will be logarithmic for 100 like this. And because 2 to the power of 9 is 500, then in the worst case, this will cost only 9 accelerations. Okay, that is the correct answer. How to do that? After we accelerate one, then we can do accelerate two. And what will be in the result? Because this is moved by 2 here and this is moved by 2 here. We can make sure we can make all of them empty, right? And then move to here and move to here. So there will be 4 empty cells. And after that, we can accelerate by 4. So what will be the result? If we move it by 4 and this is moved by 4 and so on. So we will get 8 empty cells and so on until all of the cell is empty. Okay, you got the idea. Any other question about this problem? You may ask if there is a difficulty or still don't understand about some things, or even you get another nice conclusion, you can share to me after we accelerate. Yes, of course. So here is not always 0. If it is 0, so just left it 0. But if here still 1, then we can make sure that here is only 1 microbe, not more than 1. So we can just experiment here so that the cell will be empty. So there are 2 possible cases. Sometimes it empty directly, or if it is not empty, then we can empty it by to experiment here. And we can make sure that the experiment is successful because it is impossible to have 2 microbes here. Okay. Any other question, or do you have another nice conclusion? Or maybe you can improve the problem. What if the problem like this and then the solution will be like this, maybe? Let's say in problem I, sorry. What if the cost is not sailed, so only n divided by k? What will be the solution? For example, like that. If you want to improve the problem. Okay, any other question or any comments about this problem? What does prime number contribute? In order to make the greatest common divisor is 1, because the greatest common divisor between 2 times number is always 1. For example, 90 and 23, 1. What if the greatest common divisor is not 1? Let's say n is equal to 2 and then m is equal to 4, then we cannot solve the problem. How? Because let's say there is an empty cell here. After we move, we will get 2 empty cell and then 3 empty cell and 4 empty cell, and then the next empty cell will be here again. So we will never empty this position except we sacrifice one experiment. Let's say we do a failure experiment here, do one failure experiment, and then we can solve the problem. Okay. Okay. Any other question? And the other interesting solution is there is a solution that the score is 96. How? Actually, we can make it twice by only move to the right. How to move to the right by 1? Because n and m is two distinct prime number, then we can find a value x that x modulo n is 0 and x modulo m is 1, like this. So we can move it by 1. After that, we can move it by 2. So we got 4 empty cells here. How to do that? We can find any x that modulo by n is 0 and the modulo by m is 2. Okay. Because the value of n and m is small, so we can find the value of x by brute force by try 1 by 1 like this. And then we can multiply it until on the row is empty. So the complexity is logarithmic n, right? And then after that, we can do like this again to the other row. Move by 1 and then move by 2 and so on. So then the total complexity is like this. And the worst case is 5 plus 5. And then the number of acceleration is 10. So the score is not full, but it'll be higher. That is 96. Okay. Okay, after interactive problem, I propose about graph. What do you think? Or do you have any suggestion about any material? Do you want to study about probability? Okay, maybe. Yes, I want to try to find some problems about probability and expected value. Okay, thank you for your suggestions. Okay. If we use this solution, we got 10 acceleration. And then there is another interesting solution that the score is 99. Why? At first, we will sacrifice one one failure experiment. So we will get to empty cell. So because this is start from two, then we only do for acceleration like this. Okay. But the full score, the solution of the full score is what I explained before. Okay. I think problem M, some of you already got accepted. How about problem L? You have got 50 or 47 points. Okay, I think I have to explain faster about this problem. So basically the problem is like this. There are some male and female and male and M female. And then we want to find a case that get acquaintance with 0 or more than 1. Not exactly 1 like this. Actually, we can just do like this. First, we have to query all of the male, let's say. Or let's assume the number of male is less than the number of female. And then after we query all of the male, if there is a female that is not in the response, then that person is the answer, is the unusual case. Okay. But if all of them is exist in the response, so there will be some male that acquaintance with more than one female, right? So we have to find that person in the male. How to find it? We can just do binary search. How to searching it? We can just try to query health. If the number of female here is same as the number of male, then the answer should be in the other half. In the other half should be more female here. Okay. But if the number of female is more than the number of male, then just continue paid research. We can try to ask another half and so on until we get only one male that has with 10 more female here. Okay, and that is the unusual case. So the total complexity is logarithmic n plus one because at first we query all the men. Yes, of course, there can be a man with not paired with anyone, but if there are If there are more than one unusual case, we may output any of them, right? So we may output any of them. So because we can make sure that there is a man that paired with more than one woman, then we can just find that person. Okay. And we don't care whether there is a man with no woman or another man with also more than one woman. We don't care about it. The important thing is we got at least one man that paired with more than one woman. Okay. That's why if we ask a half of men, then the number of women is more than 4, like this. Then there should be at least one man here. The proof is using pigeonhole principle, right? Okay. If there are 7 men and 6 women. Okay. If the number of men is more than the number of women, so we can just do binary search in women. So at first we query all the women and so on. Okay. So just find which one is lower, because we know that n is not equal to m. So one of them greater, one of them lower, one of them smaller. Okay. So let's say one of men is not paired. That's why at first we solve query once with all of the women. So if there is a man that is not paired, we can directly put the answer. So the total complexity is 1 plus logarithmic minimum between n and m. So the worst case is 49, and the logarithmic is 6, because 2 to the power of 6 is 64, and then 1 plus 6 is 7. Okay, any question about solution? Then only one problem left, but I think it is not necessary to discussing it. And if you want to ask, you may ask it, but not a problem if you don't get full score in this contest. Just try your best and do more practice. Okay. I think that's all our discussion for today. And let's continue in the next Monday, I think. Mr. Ahmad Usman say to me that there will be another class in Monday. Do you heard that information? Yes, okay. So see you in the next Monday, and let's close our discussion with pray together. Subhanakallahumma wa bihamdika asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Ya, wassalamualaikum ala nabiyina Muhammadin walhamdulillahirabbil alamin. Wassalamualaikum warahmatullahi wabarakatuh.
Allah Hafiz, sir.
Thank you.